Hello, and welcome to a Learning for a Cause video lesson. A transcript of this lesson is available on our website. For more information on live tutoring, please use the link in the description. Hello, and welcome to the normal distribution video.
What are normal distributions? A normal distribution is a function that represents the distribution of random variables in a symmetrical bell-shaped graph. We can see this when we look at the graph, as the graph itself represents a bell shape and is symmetrical on both sides with the probabilities on being either side of the mean being equal. A normal distribution is what is used for a variety of different statistical calculations as a baseline. And a good rule of thumb is roughly 68% of the values are going to fall within one standard deviation, 95% are going to fall within two standard deviations, and 99.7% are going to fall within three standard deviations of the mean.
The Z-score is a statistic that represents the number of standard deviations that a value is either above or below the mean. They are commonly used to standardize the magnitude of values across multiple sets of data.
Calculating the Z-score. The Z-score can be calculated by subtracting the value in question by the mean of the dataset and then dividing that by the standard deviation. It is important to note that the Z-score can be both positive and negative, as the value you are finding can be above and below the mean. When looking at the Z-score formula, we see mu to be the population mean and sigma to be the standard deviation. X is the given value in question.
The area under a normal curve tells us what percentage of the distribution falls within a set of values. Under the entire bell-shaped normal curve, the total area is 1. If you look at the shaded area, the red part, we can see that 0.0694 is shaded. This means that in this particular example, the probability of a random variable being in the shaded range would be 6.94%.
Percentiles. A percentile is defined as the percentage of values in a distribution that fall below a given value. In most cases, this is used to determine your relative position within a distribution. So percentiles are based also on the previous concept of areas under a curve, as a given percentile is telling you what value is greater than a given area under the curve. For example, looking at the pictures, you see an 80th percentile, which would be a value that is greater than 80% of values in the distribution. This is commonly used to standardize test scores.
So the first thing we're going to be going over with the calculator section is how to calculate the area under the normal curve. So the first thing you're going to want to do is click on the menu option for the TI Inspire and go over to probability section 5 and locate distributions, and you want normal CDF. And under normal CDF, it's first more important to enter in what the population mean of your distribution is. So for this example, we're just going to use 0 and what the standard deviation, and I'll also use 1 for this example. Now the lower bound and upper bound. For the lower, if you want to measure if something is less than a value, this large value is basically the same thing as negative infinity, and if you get rid of the negative sign and put it in the upper value, that's basically positive infinity, and using those is in order to get the area that's either completely greater or completely less than. But for this example, I'm going to be doing between two points. So let's say -2 and 1. And so that would give us 0.818595. And now let's look at a visualization of what that looks like. As you can see in this example, it's the same thing as before. The mean is 0 and the standard deviation is 1, and we're going to be looking at the area between -2 and 1. And as we can see down there, it is calculated as 0.8186, which is just rounded of what the calculator gave us. So the next thing we need to find on the calculator is how to get the Z-score. And the same with the last thing, we're going to look in menu and go to probability, then distributions, but now we're going to go to inverse normal. The first thing to note is when you're looking at getting the Z-score, the standard deviation will always be 1 and the mean will always be 0. The area is always going to be the left side, the left tail. So I'll show you what that looks like in a moment with a visual example. But let's say we want to look at 0.4, and it has to be entered as a decimal, not a percent. So make sure it's a decimal, and we'll be able to see what the z-score of this is. Okay, we have negative 0.253347, and let's go look at a visual example of this. So here's a visual example of what I just did on the calculator. As we can see, we were looking at a normal distribution where the mean is 0 and standard deviation is 1, which will always be the case when you're looking to calculate the z-score. And the area on the calculator will always be the left tail. So as you can see, this shaded region is referring to the left-hand side of whatever z-score we're looking at. So even if the z-score is all the way over here, it's going to be looking at this very large area. And as we can see, this is 0.253, which is just rounded of what the calculator gave us.